We want to discuss here the difference between permutations and combinations. And one thing you've seen in Dr. Mosley's videos is that the order matters for permutations. So I want to show you how to do this, a few of these on the calculator. So if I have 10 students in a classroom and I want them to go for a race, so you go out and run around the building as fast as you can. And I want to see how many different ways they can come in first, second, and third. Well, if we have Ed and Megan and Sarah are very motivated, and I tell them first place is a big Reese cup, second place is a nice Road State pen, and third place will give you a nice hug. Well, Ed is extremely motivated because he loves Reese's. So he runs really, really fast. He comes in first place, gets the nice Reese cup. Megan comes in second, gets the Road State pen, and Sarah comes in third and gets a nice hug. Well, they want to do it again. So we go out and we run as fast as we can again. And this time Sarah's like, I want that Reese cup. So she comes in first. Ed comes in second, gets the nice Road State pen. And Megan comes in third, getting the nice hug. Same 3 people out of these 10 people, but it's a different order that they came in. And that's why the order matters, because they get a different prize. So in permutations, when you're looking for the number of different ways you can come in first, second, or third, or if you're running for a certain position and the most votes gets president, the second most votes gets vice president, the third most votes gets secretary, that matters. So that's where the order matters. And that's your permutation. So in this particular problem, I said there were 10 students, and I want to know how many different ways they come in first, second, and third, so my R is 3. So if you remember the formula from Dr. Mosley, it would be 10 factorial over 10 minus 3 factorial, or it's n minus r factorial, or 7 factorial. Okay? Now the difference between, and we'll come back and calculate this on the calculator, the difference between permutations and combinations, if out of those 10 students, I want to pick 3 students to come carry boxes with me, whether I pick Ed first or Sarah first, it doesn't matter. If Ed, Megan, and Sarah are the 3 students I pick, it doesn't matter who I pick first. It's the same 3 students. If I choose another student other than Sarah, then it's a different group. So this group only counts once, no matter the order I pick. So this becomes 10C3. So if you remember from the formula, this one would be n factorial. Again, we do the 10 minus 3 factorial, which is 7 factorial, but we also divide by r factorial, or 3 factorial. And both of those come from the formula. Okay? So doing this on the calculator, remember I told you my favorite button was stat? Well, what do you think my second favorite button is? Being that I'm in the math department, it is math. Oops, turn it on. So if I do math, clear this out, over to PRB, okay, you'll see 3 options. We have NPR, NCR, and then there is a factorial button as well. So for both the NPR and NCR, it will give us these directly, but we do have to put the N in first. So my N here is 10. Go to math, over to PRB, down to NPR, and then put my 3 in. And it gives me 720 different ways these 10 students can come in first, second, and third. You can also use the factorial instead of writing. Remember, writing this out would have been 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That's what a factorial means. Over 7 times 6 times 5 times 4 times 3 times 2 times 1. These all cancel. And we're left with 10 times 9 times 8. 9 times 8 is 72 times 10. However, you can do this also. We can say 10, go to math, PRB, down to the factorial button, divided by 7, math, PRB, factorial, and we still get our 720. Okay? So let's do the combinations using the calculator. We're going to put in our n first. Then go to Math, over to PRB, down to NCR, and then put in our 3. So there's 120 different ways I can choose 3 students to go help me carry boxes.